Welcome to the 6th grade podcast. This is Mr. Gonto. I'm joined by Ms. Canario and Ms. Brown. Today we're going to talk about energy. We're going to talk about the relationship between potential and kinetic energy. We're going to interpret the relationship between potential and kinetic energy. And we're going to also talk about energy conversions. Energy is all around us. Energy is the ability to do work. When we talk about energy, we're really talking about two types of energy that we're going to discuss. We're going to talk about potential energy, which is stored energy, and then we're going to talk about kinetic energy, which is energy of motion. Now, the picture here shows a baseball, and it's going up and down. An object, that baseball, has a certain amount of energy, and as we throw that baseball, as the baseball's moving, it has kinetic energy. Well, it also has potential energy. The gravitational potential energy that object has is due to its position, how high it is above Earth's surface. So as the ball goes up, it's gaining more gravitational potential energy, while its kinetic energy is going down. And then it'll reach a point where it reaches that top point where it no longer is going up, and it's getting ready to start coming back down. At that highest point, that's when it has its highest amount of gravitational potential energy, and it'll have its lowest amount of kinetic energy. But then as it starts to come back down, the ball will gain in kinetic energy, and the gravitational potential energy is then converted into the kinetic energy. So the gravitational potential energy will decrease. Like I just said, the gravitational potential energy depends on weight and height from the ground. So if two objects weigh the exact same amount and they're the same distance from the ground, they have the same gravitational potential energy. If you want to change the gravitational potential energy of an object, you have to either change the weight or the height of the object. So if we have a book that weighs 2 pounds, that's 3 feet off of the ground, that gravitational potential energy, it would have a gravitational potential energy of 6. To change it, you would just lift the book higher or put it lower to the ground to change the gravitational potential energy. Another type of potential energy is elastic potential energy. This is energy stored by stretching or twisting. This is when you change the shape of an object and it returns to its original shape. You have to apply kinetic energy to it to change the shape of it, and then it will spring off. A spring, a bow and arrow, a rubber band are great examples of elastic potential energy.
Another type of energy is mechanical energy, where we have potential and kinetic energy working together. It's basically anytime you see movement, you are seeing mechanical energy. Next, we have thermal energy, the motion of atoms because of the temperature. So the faster those molecules are moving around, the more heat that we're going to have. So when we're building a fire and we have a fire going, the heat that we feel off of the fire, that would be thermal energy. Chemical energy is the bond that holds atoms together. So like anytime we eat food, our body is storing that energy, and that's chemical energy that it's storing, so we would have the ability to move. So another example of that would be batteries or like chemicals that you would use to burn something. Electrical energy, the energy of moving electrons. So anytime we have electricity, we're using electrical energy. So when you plug in your cell phone to charge your cell phone, you're using electrical energy. Watching a television, static electricity, all of those are examples of electrical energy. Sound energy, the movement of energy through waves, such as playing a guitar or singing. Anytime you're hearing something, you're hearing sound energy. Light energy, vibrations of electrically charged particles. So we have the many different kinds of light energy there. The one that we see the most is visible. We get light energy from the sun as well.
Alright, so the first type I want to talk about is gravitational potential energy. That's really simple because it's got it in its name. So gravitational potential energy is the energy stored in an object because of its position, because gravity can pull it down. So I'm going to put that here. I'm going to abbreviate it as GPE. All right, the next type is elastic. Well, elastic potential energy is also potential because the energy is stored in the object because of the stretching or twisting of it. So it's stored energy, so potential energy. Okay, the next type is chemical energy. Well, chemical energy is like what's stored in food or stored in batteries or stored in gasoline before it's being burned. The energy's there, It's not actively being used, but it could be transferred into another type of energy, a type of kinetic energy, if it were being used. So the key word there is stored energy. So it's chemicals here. All right, then we've got thermal energy. Thermal energy is when you add heat to things and it causes the particles to move more, or the molecules of that substance to move more. Well, if the molecules are moving, then it is kinetic. Okay, light energy. Light energy is basically the vibrations of the electrically charged particles. Again, the word vibrating or moving causes it to immediately be kinetic. Next is sound energy. Well, sound moves in waves. Waves are moving. It's not stored. It's actively moving. That makes it kinetic. Okay, mechanical energy is a little tricky because it's by definition, it's the potential and the kinetic energy. It's all things that are moving, and since they are moving, we will categorize it as kinetic. Just making sure. All right, and then lastly, we have electrical energy. Well, electricity, which is electrical energy, is simply energy that is made from electrons, and those electrons are moving. If they're moving, it's kinetic. Okay, so that's how all of our different types of energy fit into either potential or kinetic energy categories. So now that we know the types of energy, let's talk about the conversions. There's this really, really important thing called the law of conservation of energy. It's a scientific law, which means it is always, 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 always true. Always, 100%. Okay? Conservation. We're keeping what we have. We're saving it. We're not making more. We're not destroying it. We're conserving it of energy. Okay, so this means that energy cannot ever be created or destroyed. So what happens to the sound energy when I talk? Well, it's being changed into something else. What happens to the electricity that's running through the outlets in the wall? Well, when you plug things in, that electrical energy changes into light and heat and sound depending on what you're plugging in. So the key here is the energy changes from one type to another. It's not destroyed, it's not created. Okay, so let's look at some simple examples. Okay, the chemical energy, which is stored in sugars, is being broken down. It's stored for you until you eat it. When you eat it, it's broken down by digestion and allows you to use it as mechanical energy. Okay, the light energy from the sun, okay, through photosynthesis allows trees or plants to create their own food. Well, food is chemical energy, stored energy. Okay, the gasoline that you pump into your car is stored energy. It's not moving, but it allows your car to move and have mechanical energy when it burns it, chemical to mechanical. And lastly, electrical energy is electricity. It's in your walls, it's in your outlets. If you plug in a stove and you turn that stove on, it converts the electrical energy into thermal energy to allow you to cook. So let's do a couple of more complicated examples. The first one we'll talk about is a hydroelectric dam. So the way a hydroelectric dam works is there's water here, then there's a dam, and then there's water here. And when the operators of the dam want to, they can let the water through the dam. So when it's here, the water has GPE, gravitational potential energy. Okay? As it comes down, it has that GPE, that gravitational potential energy, changes into mechanical energy. Okay? What happens inside the dam as the water comes through is it rotates these things called turbines, which also have mechanical energy because they're spinning around. Well, those turbines are connected to a generator, and that generator allows the mechanical energy of the spinning motion to be generated or changed into electrical energy that you use, that gets sent to your homes and to our schools. And since we live in the Tennessee Valley, a lot of our energy is created this way. Let's do another example, and this one's a little harder because you may not know how these work. But let's do a coal power plant that burns coal. Okay, so the way it works is they take the coal and it has stored energy, okay? Because coal is made from plants. So the stored energy in the coal is burned, okay? And that creates a lot of heat. So we go from chemical to thermal because it gets really hot, right? Well, that thermal energy is then used to heat up water, okay? So chemical energy in the coal is set on fire to create thermal energy, and then that thermal energy is used to heat up water. Well, if you heat up water with thermal energy enough, the water will evaporate and create steam. So what happens is they gather that steam in a tube, okay, and that steam is moving down the tube, okay? Moving energy is called mechanical energy. So now we've gone from chemical to thermal to mechanical. Well, that moving steam will eventually hit another turbine, just like we had in the hydroelectric dam. So the steam causes the turbine to spin. We're still having a mechanical energy there because we're still having movement. So now that spinning turbine is connected to a generator, and the same as with the hydroelectric dam, the spinning turbine will change the mechanical energy into electrical energy and electricity for us to use. So in a coal-powered power plant, we go from chemical energy stored in the coal to heating it up, causing it to burn, which releases thermal energy, which makes steam, and the steam moves, so that's mechanical energy, which moves a turbine, which is also mechanical energy, which creates electricity through a generator, so electrical energy. Those are some just more complicated examples of the different transformations of one type of energy to another. One thing I do want everybody to be aware of is every time energy changes from one type to another, there is always a little bit of thermal energy that's created. Okay, no matter what conversion we do, most of the time it's obvious, especially when we have electrical and light and mechanical involved. But no matter what, even with sound, thermal energy is created through every conversion. All right, so that's all we've got. If you are having trouble understanding this through the video and with your notes, please come speak to one of your science teachers and we'll get you straightened out before the quiz.